Hello and welcome to another Oxford Sandy and Black Pig Group podcast. I'm your regular host, Andrew O'Shea. This episode of the podcast is a replay of the event that we held back on the 15th of November with a lady called Victoria Phillips, who's one of the leading pig nutrition experts in the country. She's talking to us about feeding for efficiency and how to get the most out of our pigs with what we feed them. Before we get onto that, there's a few items of news. So the first being is that those that remember last year, we hosted the Big Fat Pig Quiz. It was well attended and we raised a fair bit of money for charity through the auction on that day, and there was a £100 cash prize. We are running the same again this year, Friday the 23rd of July, 1900 hours. Again, it's hosted via Zoom. Tickets are £3. The winning team will win £100 in cash, plus there'll be the option of the auctions throughout the evening. If you want the tickets, they are available in our shop. Head on over to Oxford Sandy and Black Pig Group.org and click on the Our Shop button from the top menu, and it's one of the top 3 items in the shop that you'll see there. In addition to that, the butchery series is going well. Episode 3 was released a few days ago, where Nigel talks us through the loin, so we can take the meat off the bone for making our bacon, and how to make some chops and some pork steaks off of the rump of the loin. We also have now t-shirts in the shop, our Oxford Sandy and Black Pig Group logo t-shirts. They are priced $19.99 and available in sizes XS through to 7XL, so we cater for everybody. Not all items are in stock, but they can be ordered and we can get them from the manufacturer made and sent to you. It just takes a little bit longer than the ones that we do have in shop. If you have any questions about that, you can just reach out to Kim, myself, or one of the other trustees, and we can direct you. You'll also remember the study that Kim and I and the rest of the charity are doing in regards to farrowings. So far this year, we've had 527 piglets born from 61 litters. Now that number is based on piglets alive at 1 week of age. 261 boars versus 266 gilts, so pretty much a 50-50 split down the middle. The Alisons and Gertrudes are probably one of the most popular lines being bred this year. We don't have any recorded births though within the group for Elsie or Lady. So if you are breeding Elsie or Lady bloodlines, please do reach out to Kim and I and let us know what you're doing. That's enough of my waffling in the news. Let's hand over to the replay of the event with Victoria Phillips. Right, so good evening everyone. So we're lucky to be joined tonight by a lady called Victoria Phillips, who I had the pleasure of meeting a few weeks ago on an AHTB presentation regarding feeding your pigs and the nutrition and the efficiency behind it. We get a lot of questions on the group around, my pig being too fat, or it's not growing fast enough, or, I'm putting all this through it. What do I do with this waste food, etc., etc. And the science behind understanding how pigs put on weight is really interesting. And I spoke to Victoria, and she's quite happy to give this presentation. And I believe that everyone on this call will benefit from the science behind, how pigs turn protein into meat and fat, etc. Very, very interesting. So good evening, Victoria. Thanks for joining us.
Hi, Andrew. Thank you for inviting us. It's lovely to be invited and to see so many people turn out.
Yeah, thank you very much.
Evening, so, yeah.
So I'm going to hand over to you in 2 seconds. So again, just a reminder, if you want to ask a question, you can either use the raise your hand option for the reactions at the bottom, or you can just type a message in the chat. Kim will be coordinating any messages. Feel free to ask them throughout rather than wait until the end. Victoria's happy to field any questions as you go along. So without further ado, thank you very much. I'll hand over to you, Victoria.
Okay, thanks, Andrew. Right, so I'll just do a quick introduction. So I was been a nutritionist in the feed industry now for about 26 years, and I've worked in big feed mills, small businesses. I work now along with my colleagues who are in the audience tonight, working with all different types of feed businesses, large and small, farmers, food businesses who place feed onto the market, really just acting as a advisor, consultant, helping people through the sort of legislation and assurance schemes and all those kind of things. So I put this together very much as a sort of an overview of feeding pigs efficiently. I could probably talk for 2 days on this subject, so I have condensed it into 20 slides or something of key points that I wanted to cover tonight. And so I would just like to say thank you to Andrew and another lady who was on the AHDB course for the very cute photos. Got some lovely photos in this. They're not my pigs, I'll just say, but there's some really nice photos in here as well. So what we're going to talk about tonight, 3 sort of main topics to cover. We're going to talk about, I'm going to start by doing an introduction and explaining about some of the key nutrients that we have to consider when we're looking at rations for pigs and looking at feeding to get carcass composition. We're going to talk about feed intake. We're going to talk about what makes a pig eat and how we get them to eat what we want them to eat. And I think there's somebody who's not on mute. Could you just all have a look, because I can just hear some background noise.
Hello everybody, can you just make sure you're all on mute, please? We've got some lovely background noise, so we can...
I might be able to mute, actually, whoever it is. Yeah, well, look, Jared.
Who is it that's not on mute?
I think it's
Stephen
Jared.
Edmund. Can you go on mute, please? Please, thank you. Can you also go on mute, please?
Jared, could you please mute your microphone?
What?
No, I'm not. I think there's still a couple of people who want, but hopefully I can.
There you go.
Okay, brilliant, thank you. So I'm going to talk about what makes a pig eat and how to get them to eat what we want them to eat. And then I'm also going to just finish off by looking at carcass composition. And what I've got a presentation of slides, and then I've got a very simple Excel spreadsheet that just shows the sort of the key nutrients that we're going to talk about. And then what happens when we change diets around and supplement diets, and what we think are probably small changes or small additions to a diet, and what that can actually do for carcass composition. And so I know from when I did this course for AHDB, I know that people feed pigs in a number of ways. So there'll be some people who are just buying commercial pig feed and feeding that with nothing else. There'll be some people who are home mixing completely and buying in different ingredients and mixing them together. And there's probably a number of people who are buying commercial feed, but then possibly supplementing it with maybe some bread or some vegetables or something that looks tasty and that the pigs like. And so that's what we're really going to look at towards the end, is what that does in terms of how it affects the diet and then how that affects carcass composition. So just to, as I said, I'm going to start off by just explaining some of the terminology that I'm going to use and some of the key nutrients that we have to look at when we're feeding pigs. So when we talk about feed, and this is any feed, whether it's a commercial pig pellet or whether it's a single feed like bread or vegetables or soya or something, then feed is made up of the water fraction, which can be very variable, and everything that's not water becomes part of the dry matter. And within that section of dry matter, we have both the organic and the inorganic constituents. And I always like to think that if you imagine the animal being a bit like a car, So we have the protein fraction, and the protein is the bit that you can see, if you like. It's the rubber for the tires, it's the metal for the doors, it's the glass for the windows. And so we're going to look at protein, the building blocks, if you like, of the animal. And in particular, we're going to look at something called essential amino acids. So we'll come back and we're going to look at that. The energy, if you like, in a diet, which comes from carbohydrates and fats and oils and a little bit from fiber, is like the petrol that you put in the car. You can't see it, but that's what makes the car run. That's what gives the energy to actually make the animal walk around and grow and produce milk if it's lactating. And within that fraction, we're going to touch very briefly on something called essential fatty acids, which are specific fats that must be fed in the diet in order to keep the animal healthy. And we're going to, again, just touch very briefly on the vitamins and the inorganic fraction of minerals, which can be described as nutrients that are needed in very small amounts, but are essential to the health and well-being of an animal. And that's, I always compare those things to, for example, the oil in the engine or the water in the radiator, or those kind of things that don't seem very important until you run out and then the car stops. So as I said, I'm just going to give you a sort of an overview of the importance of some of these nutrients. And then that helps us to then, when we start looking at the ration further down, you know exactly what I mean when I'm talking about essential amino acids or essential fatty acids. If we start by just talking about protein, so you're probably all familiar with looking at the protein content of your feed, whether that's the pellet that you've bought, the commercial pellet, or whether that's perhaps looking at the protein content of some of the other feeds that you feed alongside that. So protein itself, as I said, proteins are the building blocks. Proteins make up things like muscle, tissues, hair, skin cells. They also are hormones, enzymes, antibodies, all of those sort of key factors used in metabolic processes. They are also proteins. And the definition of a protein, as you can see in this diagram here, a protein is a chain of amino acids. It's a chain of building blocks, which give the protein its unique properties. So you can see that a particular protein has a template, if you like, an exact template of amino acids. And for a protein to have a particular property, to do one of these jobs, then the amino acids have to be in exactly the right order needed for that particular template. And one of the thing that makes protein different to all the other nutrients is that it has an amino group on it. It contains nitrogen, whereas the other nutrients don't contain nitrogen. They're just made up of carbon, oxygen, and hydrogen. Okay, so we're going to look in a bit more detail at these amino acids, these building blocks of the protein, because when we're looking at different diets and different feeds and we look at a protein content, the protein content as a whole doesn't give us a lot of information about the quality of the protein, i.e. the makeup of the amino acids. So there are 25 amino acids or their precursors, and these amino acids can either be supplied in the diet, or some of them can actually be synthesized by the animal themselves. So when we're talking about pig diets or poultry diets or human diets or dog and cat diets, animals that are considered to be monogastric animals, single stomached animals, then we have to supply 10 of these amino acids in the diet. There are 10 particular amino acids that the animals can't synthesize. So they can't take one and change it into an essential amino acid. We have to supply them in the diet. And so I've given you a list there because some of you may be familiar with certainly the top 3 amino acids are quite commonly found on the labels of commercial pig feeds. There are 10 in total, but they do sort of decrease in order of importance. So generally speaking, for pigs, the lysine is sort of the top essential amino acid. It's the, if you like, the one that is probably lacking most in pig diets. And as I said, these essential amino acids have to be supplied in the diet because they can't be synthesized by mammals by transamination. So transamination means moving the amine group, yeah, taking a non-essential amino acid and turning it into lysine. So what I've got here is a sort of, if you like, a picture of a protein. This is, for example, a muscle protein. And you can see that I've made a template, if you like. This is the exact template that is required if an animal wants to lay down a muscle protein, if you like, as part of growth. It could also be if an animal wants to regenerate skin, or if it wants to produce a breeding hormone or an antibody or an enzyme. It would be exactly the same process. But for example, this particular muscle protein has this exact template. So you can see that the empty circles will be the non-essential amino acids. If we're a bit short of one, we'll just make it from something else. Yeah, they're not essential in the diet. But then we have this template of protein where we've got the essential amino acids. So we've got histidine, lysine, tryptophan, lysine, arginine, all the ones from that list that I've just showed you. And in order for an animal to grow, they have to produce this muscle protein. They have to lay down this muscle protein. So we have to give the animal enough of these essential amino acids in their diet in order to be able to make up this exact template. And the problem that we have in modern diets is that, generally speaking, they tend to be based on vegetable proteins, which naturally have low levels of lysine, methionine, threonine, of these essential amino acids. So often we could put a diet in that looked on paper like it had very high levels of protein, but that protein could be made up of a lot of these non-essential amino acids and potentially very low levels of lysine, methionine, and threonine. And so what we've got here in this picture, this is what we need to make. If we want the animal to grow, we need to make this muscle protein. And these are the amino acids that are present in the blood, and they've come from the diet. So the animal eats a protein, they digest the protein, the long chain, into its constituent amino acids, absorbs the amino acids out of the digestive tract into the blood, and then those amino acids are then circulating in the blood to be taken to wherever they need to go, to be put back together again in this template. Okay, so you can see here what I've done. These are floating around in the blood. And so the animal is going to start making this protein. So we have plenty of these empty circles. We have plenty of these non-essential amino acids. And we've got a histidine and a lysine and a tryptophan. If I was cleverer, I'd have made these little red rhombuses move, but I'm not that good on PowerPoint. So if you can just imagine, there's another lysine, there's an arginine, another non-essential amino acid, there's a phenylalanine, there's a methionine, and another tryptophan, and a valine, and just bear with us, a leucine, and another tryptophan, and an isoleucine, and another lysine, and a threonine. And eventually we get to this point here. So we've almost made this protein. We're just about at the end. And we realize there's no methionine. There isn't any more methionine left in the blood because the diet has been low in methionine. And because this is an essential amino acid, the animal can't take this spare valine or this spare non-essential amino acid and turn it into methionine. They can't do that by transamination. So in practice, what happens is the whole of the muscle protein is broken down and has to be excreted. There isn't enough methionine there to make what they need. So these amino acids, they can't make the protein because they're lacking in the key amino acid, and they go off to the liver and the kidney to be deaminated, which takes energy, actually uses energy to then take these amino acids, and then eventually they're excreted as urine. And so that has a number of disadvantages. So we haven't built the muscle protein, which means the animal's not going to grow, or it's not going to produce the fertility hormone, it's not going to produce the antibody, it's not going to produce the enzyme, it's not going to produce the skin, the hair, the tissues, all of those things that we were talking about that are made up of protein. It's going to actually utilize energy to break down that protein. The body can't store excess amino acids. If they're not needed, they have to be. Excess nitrogen in the blood ends up actually being dangerous. So they have to be taken to the liver and the kidney to be deaminated, i.e. the nitrogen group removed, and then they have to be excreted. So potentially then you're looking at high levels of nitrogen as pollution. And all these lovely essential amino acids, all this precious protein, if you like, have effectively been wasted just because we were missing one amino acid of methionine. Yeah, it's so when we're thinking about, when we're talking about this, when we're talking further, if you can try and keep that in your head, I've actually pulled them in there for this. These are all spare, and we got stuck there. So effectively, none of them can be used for the building blocks of the growth or the enzymes or the hormones. And effectively, we've just wasted the world's precious resources of these essential amino acids. So in commercial pig diets, they know exactly the proportions of lysine, methionine, threonine, tryptophan, etc., that are required for pigs at different stages of life. And so they can buy neat lysine, you can buy pallets of neat lysine, neat methionine, neat threonine, neat tryptophan, and they will add essential amino acids to those commercial diets to make up to just exactly what the pig needs. They won't feed more than they need, but they will top up, if you like, to that minimum point that is required. So with this one here, they would have just added a little bit of methionine. And then once we've got that, there's your arginine, there's your spare non-essential amino acid, there's your valine, and there's the muscle protein, and the pig grows. Yeah. So the commercial diets are very much balanced in that way to ensure that there isn't that wastage of other essential amino acids, and the animal maximizes its growth potential. When we start adding things to commercial diets, or when we mix our own in a home mix ration, that's when sometimes you can get these inequalities in essential amino acids, and sometimes end up possibly overfeeding protein, but underfeeding the essential amino acids. So sources of protein, like I said, often our modern diets are based on soya. Feed a small amount of rapeseed meal to pigs, not a huge amount. You can feed linseed, they like linseed. And we can feed fish meal to pigs as well. Fish meal, being an animal-based protein, does have much higher levels of essential amino acids naturally. And you may find that there isn't really a requirement to supplement a diet if you're using fish meal. But if it's a vegetable-based diet, being based mainly on soya, then it probably will be lacking in lysine, but overfeeding some of the other amino acids. And it's always good to use the opportunity to point out all the things that we can't feed. Remember, it's illegal to feed any meat products, any animal byproducts, with the few exceptions of, for example, pasteurized milk and eggs. But no meat or meat derivatives can be fed to pigs. No catering waste, so nothing can be fed from a household kitchen or a commercial kitchen. Nothing that would be classified as catering waste from a restaurant or a cafe or anything like that. And that's to prevent the spread potentially of things like foot and mouth disease, African swine fever, which could still be present in those kitchen scraps, could still be present in the bits of bacon sandwich or pork pie that could inadvertently find its way into those type of products, the catering waste and the kitchen scraps. And so we can't feed any of those things. We are very much relying for our protein on these sources here. I can see, is there any questions? I can just see it, the little chat box flashing. No?
Questions?
Yeah, I was asking a question. Can I ask it now?
Yeah, of course.
Yes.
We have chickens and we have a sort of glut of eggs every so often. So is it okay to give the whole egg?
That is a very good question. I don't know, but I will find out for you.
Thank you.
So Victoria, I'm kind of a bit of a nerd when it comes to this topic, having been through reading many pages on this. So you can't feed fresh eggs or products that contain eggs to pigs where the eggs haven't been treated first to remove pathogens like salmonella and stuff like that. So when it comes to bakery waste and stuff like that, you have to be careful what you're feeding. You know, if it's raw egg icing, etc., stuff like that, you can't use that. Eggs need to be treated to a certain temperature to remove any pathogen. The same with milk as well. You see, you use the word pasteurised there, so that kills off pathogens, but you can't use raw eggs.
Yeah. No raw milk, no raw eggs.
Yeah.
So you can cook eggs and give them to them.
No, because you then would be cooking them in your kitchen, so you know that kind of stuff. If you look on our website, I'm not sure who it is that's asking the question, but if you go to Oxford Sandy and Black Pig Group website and then go on to the list down the end, there's on the menu at the top, there's an option there around what to feed your pigs, and there's legislation there that details how and what when it comes to things like eggs and milk and how it can be fed and how it needs to be treated by a registered plant before it's used in a product that can be given to pigs.
Okay, thank you.
Okay, thank you for that, Andrew.
Sorry.
No, that was fine. That was fine. I had to think. I was trying to think on my feet there, and I don't want to say something that I'm not sure about, but that was good. Right. Okay. So that's proteins. If we talk about energy, which was the petrol that drives the car, then you might be looking at the energy content of your feed. And we're going to talk about energy in relation to protein later in the session, which is why I've put this in here. So you can't really see energy, but this is what keeps everything going. So when we measure energy in pig feed, we don't measure gross energy. Gross energy is the total amount of energy that is available in a diet. The gross energy is if you put it in a bomb calorimeter and put a feed in a bomb calorimeter and burn it off until the only thing that's left is ash and measure how much energy comes off, that's gross energy. But we don't use the term gross energy when we're looking at energy content of pig feed. We use the term digestible energy, which is a measurement of the gross energy minus the energy that is going to be lost in feces. That would be the digestible energy known as DE megajoules per kilogram. Okay, and when it comes to feeding energy, excess energy can be stored. So I said earlier, excess protein can't be stored. We have to get rid of that nitrogen. It becomes dangerous if it's floating around in the blood. But with energy, we can store it as fat, and therefore there is no limit really as to how much energy a pig can deal with. That's some of Andrew's little piglets there. I wanted to just touch on this point of essential fatty acids, and you'll see why later. So essential fatty acids are certain long chain fatty acids, if you like, that make up a part of a fat source, for example. So you may have heard of things like omega-6 fatty acids, omega-3 fatty acids, which are classed as being essential, which means, again, the animal can't make them themselves. They have to be supplied in the diet. They can be synthesized by ruminants, but not by pigs. So that slide's not quite right. I think I should have had an extra bit in there. They are things like what we call linoleic acid, linolenic acid, and I won't even try and say those words, EPA and DHA. Okay, but it's not enough to just feed an amount of fat to a pig. We also need to make sure that within that fat content of the diet, there is a source of these omega-3 fatty acids, just like humans, where we need those essential key nutrients in the diet. I'll change that slide before I send it. Okay, if a diet is lacking in essential fatty acids, then potentially we're going to get deficiencies in growth, deficiencies in development, and what we call development retardation, increased susceptibility to bacterial infections, infertility, sterility, all because this one key nutrient is missing. So the essential amino acid content might be right, the energy content might be right, the vitamins and minerals might be right, but if the diet is lacking in essential fatty acids, then all of that wouldn't matter, because you would still potentially get reduced growth rates, reduced fertility, increased susceptibility to infections. So if you are home mixing, or if you are adding something to your diet, then what we would be saying is potentially you need to be looking at feeding a source of essential fatty acids. So soya oil, sunflower oil, rapeseed oil, linseed fish oil, they are all excellent. Just like what we're told to eat as humans as well, to get our source of omega-3 fatty acids, those omega-6s as well. But it is very important that, particularly in breeding animals, that we ensure that we're not just looking at fat content alone, we're also looking at supplying a source of the essential fatty acids. And then the last bit just to look at would be the vitamins and mineral content, which, as I said, is like the oil in the engine. Not that I know anything about cars, but water in the radiator, required in small amounts, but essential to the life and well-being of an animal. And when it comes to minerals, some are considered to be essential. Not all minerals are considered to be essential, but there's been a lot of research done over the years where diets that have been deficient in a particular mineral have been fed to animals, and the animal shows deficiency symptoms due to a lack of that particular mineral. So, for example, this is I've just picked zinc as a single example of what that means. Zinc is essential in the protein production. So go back to think about that diagram where we were putting all the amino acids together in the template. We could have all the amino acids present, all those essential amino acids could be present in the blood, but if there's a lack of zinc, if there's no zinc in the diet, then zinc would be the catalyst when building that protein. And if there's lack of zinc, then the animal's not going to be able to build that hair, skin, hoof, wool, antibody, hormone. In this picture here, these two pigs have been fed exactly the same diet, except this little one on the left has had no zinc, but otherwise they'll have been exactly the same. And even though all the essential amino acids, the protein and everything else would have been there, the lack of zinc has meant that it hasn't grown. It hasn't, and all those amino acids are now on the ground in the river, but they've all had to have still been excreted at a big energy cost. Potentially, you would also see symptoms like parakeratosis, scabs, scabby feet, foot abnormalities, reduced growth, other things as well. But
Victoria,
yeah,
sorry, can I get talking about zinc? There was some talk, I think it was about 2-3 years ago, that and it's still in the process now, that zinc was going to be removed totally or partially from the feed. And so I don't know whether or not this is still going to happen, but it was certainly going to be removed from the feed. And if it was, or if it is, what will what's the alternative going to be?
well, luckily it's not going to be completely removed. So zinc is actually used for 2 reasons in pig feed. There's a nutritional requirement, which is what we're talking about here, which is actually very low. I think it's no more than 150 milligrams per kilogram. But zinc oxide is also used as a medication. It's used as a sort of for post-weaning diarrhea treatment.
Yes.
And it's used at much higher levels, 3 kilos per ton. And it's used under prescription. And it's that use of the zinc that is possibly, but not definitely, but possibly going to be banned next year.
Okay.
So what I'm talking about here, there won't be any restrictions on using zinc as a nutritional additive, but certainly in the EU, they're looking at banning it from next year, and possibly we're going to as well.
Okay, thank you.
Okay, so yeah, all these little things all can affect this protein deposition and this growth and this carcass composition that we're trying to achieve at the end. And so if you can keep that in mind, what I'm going to do now is just talk a little bit about feed intake and what they like to eat and what they're going to eat. And then we'll look at growth and how they actually lay down these tissues and how we can manipulate that.
Victoria, can I just interrupt you again? I've just got a few questions that have come up.
Yeah, of course.
I've got a question that says, do some minerals affect the uptake of other minerals in pigs?
Possibly. If you overfed something like, I think, iron, massive amounts of iron, then there are only certain points in the digestive system where we can absorb minerals. So they're called active transport sites. And if you overfeed one particular element, it can sometimes lead to a deficiency of another element. And that's just because there are limited spaces of absorption, if you like, for those particular minerals. And that's why it's actually really important not to overfeed minerals. Sometimes, you think, oh, well, I'll just give them a bit more, or the more the better. But that's correctly the case, that you've got to be careful to not overfeed one to the detriment of another.
Okay. The other question was, with sheep, some minerals are not given to rams. Is this the same with boars?
I've never heard of a boar getting urinary calculi. Now, that may be because the ones I meet never get. It's to do with magnesium content of the feed. And I would imagine in theory it could, if you're feeding a diet that has high levels of magnesium in it and phosphates. The problem with sheep is that we do feed high levels of magnesium to ewes and to female sheep. So if the male sheep get access to it, then it can cause bladder stones. But we don't feed high levels of magnesium to any pigs. So I've never seen it, because I've probably never seen a pig that's ever had access to high levels of magnesium before. If that makes sense. That was a very long-winded answer, wasn't it? I would say possibly yes, but I've never seen it.
Okay, and the last one that we've got on this one is, how much essential minerals and protein do pigs get from soil and general rooting about outdoors?
Probably not a lot of essential protein, essential amino acids, but possibly minerals from the soil, depending on how good the soil is, I guess.
Yeah, I think what we're looking at here is that sometimes we have discussions about iron injections, Victoria, and some people who will bring on their pigs in an indoor unit as opposed to those on an outdoor unit will most probably say that you're getting the iron from the minerals when your pigs are outside, so therefore do not need to have the iron injection. And so we have that sort of conversation. So, and again, I think it's basically how your land is kept and how your pigs are rotated on the land. So I think that is that's where this question is coming from.
Yeah, I possibly, but I would imagine it very much depends on the nutrient quality of the soil.
Yeah. Okay, that was it. Thank you.
Okay, so in terms of feed intake, what makes a pig eat? What makes a pig stop eating? So there are 4 sort of things to consider, and I won't spend ages on this. It's just an overview, really. But there are actually metabolic factors that make a pig eat or stop a pig from eating. They are receptors in certain tissues which can detect what a pig is eating, if you like, and will either encourage it to eat or stop it from eating. There are digestive factors at play sometimes. That is sort of a physical restriction on the stomach size or a feeling of hunger, for example. How available is the feed? How easy is it for them to eat the feed? How tasty is the feed? And also the issue around how healthy they are and how they are actually able to go and get the feed. So the primary control over feed intake in pigs is a metabolic control. Pigs will eat to satisfy their energy requirements, first of all. So when the receptors in their liver recognize that there's enough glucose in the blood, for example, they'll stop the pig from eating. And so what we have to do is when we're designing a diet, be conscious that it's only going to eat first, it's going to eat to its energy requirements, and make sure that the protein is balanced for that, so that if it stops eating because it's had enough energy, it's not actually lacking in protein and vitamins and minerals and essential fatty acids, etc. In pigs, the digestive controls are not usually important, so it's probably unlikely that a pig's going to overeat. It's the metabolic controls that are in place. What you sometimes do find is for dry sows, where we don't want them to get too fat, so we are giving them a very small amount of perhaps like a general purpose sow feed, then we have to give them so little that they might get hungry and they may overeat. And in those particular cases, especially probably more likely in modern genetics where they've got a very high gut capacity, and we don't want to feed them too much. And in those particular examples, we can give straw, we can give something like sugar beet, which is low in nutrients but swells up inside them and makes them feel fuller. Things maybe like something like brewer's grains as well, they tend to be relatively low in energy but make them feel, anything that's wet, I guess, they'll just make them feel a bit fuller. And the same with boars as well. Environmentally, for commercial pigs in housing, then they tend to be quite well controlled in terms of temperature, in terms of environments. But for outdoor pigs, then temperature will affect feed intake. And I've actually got a slide, which I think is a couple of, I'll have to come back to it. This is it here, sorry, here. So when we're looking at temperatures, we're looking at the lower critical temperature of animals, and I just picked out the pigs here for this one. When we talk about a lower critical temperature, we're talking about the environmental temperature below which heat production is increased. So when the temperature drops below a certain figure, the animal will start to utilize feed for heat production rather than growth, lactation, pregnancy, etc. Okay, so for indoor pigs, this is usually quite controlled and it's usually doesn't affect them too much. For outdoor pigs, what we're saying here is for a young 40 kilo growing pig, if the temperature drops below 14 degrees C or 19 degrees if they're on concrete, then they will start to divert nutrients to heat rather than to growth. For sows on straw, that lower critical temperature is 22 degrees. So what we see, if I take poultry as an example, as a very extreme example, there's always a calculation to be done in a big commercial poultry unit If feed is cheap and heat is expensive, then they will drop the temperature a couple of degrees and let the animals eat more and divert it to heat. If feed is expensive and heat is cheap, they'll turn the temperature up and let them eat less. Okay, so in our kind of situation, they will eat more if they're outside, especially if they live in Consett in County Durham, where it's still snowing, still hailing. Then they will need more feed. And primarily, they'll need more energy. They won't need a huge amount of extra protein. They'll need more energy. It's the energy that gets diverted to heat. Flavours can be added. Pigs love different flavours. Some animals can't taste. Cows can't really taste different flavours. Young pigs particularly, can taste different flavours and they like different flavours. And if you're trying to encourage intake in young animals, you change the flavour. That's like a special treat, a bit of excitement for them. And they will potentially eat more. It encourages them to eat. Like caramel flavour. Trying to think what other flavours I've seen. There's certain flavours that they like anyway. And in terms of animal health, then if they're ill or injured, then they're not going to be able to compete for feed. So again, when we're looking at diets and the end result of carcass composition, we're trying to think of those things as well.
Victoria, we've got a question that's come up, but a comment about somebody who said they rear outdoors and they feed broccoli and kale to their pigs and they rotate on other crops like turnip and peas. Can the pigs overeat on minerals and vitamins when they're out and about like this?
I would say not. I would say that is an example where gut capacity would probably limit intake. And those, with the except peas would be high in protein. The other crops would be very low in both protein and energy. So I would imagine, I mean, they would have, well, for example, the broccoli and kale would have high levels of iron, but I think that would be fine. I don't think they could actually overeat enough to have an adverse effect on, for example, the calcium absorption. I think physically they probably couldn't eat and digest enough to get to that point.
Okay. And feeding apples and windfalls, how does that, is there any benefit or not benefit? It's just a filler like sugar beet and...
Can I leave that one till the end when I get my spreadsheet out and I'll show you that. And I'll show you what, apples are slightly different because they are sugary and they do have energy in them. They're different to things like kale and broccoli, which wouldn't have a lot of energy in there.
Okay.
But I'll come back to that one, if that's okay.
Okay, thank you. And the last one is about the feed. We normally say that a pound of feed per month of age. And how does, so with that in consideration, it says, how does the temperature affect that volume and intake? So
I have got a slide on amounts that they'll eat in a minute, but it's probably more
okay. Well, no, we'll leave it till that. We'll leave it to them. That's fine.
Let me come back to that one as well.
Thanks, Victoria.
Okay, so as I've just said, pigs will choose, if you like, and they don't realise they're doing it, but they choose to satisfy the energy requirement first, and then after that, they can pick out. They're actually very clever, and they can pick out protein. And so, given two diets with equal energy content, I just wanted to show you this. This was a trial that was done many years ago now, but I think it just shows like how clever it is, really. The two diets are provided. So pigs are in a pen. There's 6 groups of pigs, and they are given 2 separate diets, completely separated. So imagine a trough on either side of the pen. And you can see from this is diet 1 in the pen, this is diet 2 in the pen. And the options within the groups, a diet that's very low in protein and quite low in protein, a diet that's very low in protein and quite high, and a diet that's very low and very high, and then a diet that's quite low and quite high, quite low and very high, high and very high. Okay, so you can see that there's quite differences in these groups. And the pigs are allowed to choose how much they eat of either diet. They themselves decide how much of each they're going to eat. So in this top group here, you can see that they had the biggest intake. They were trying, if you like, to eat more, but bear in mind that both of these diets would have had similar energy content, that eventually they eat to fulfill their energy content and they're not going to eat anymore. But you can see how they clearly picked a larger proportion of the higher protein diet, but even then, they only managed to achieve a 16% protein content. And at the bottom, the opposite end of the scale, where they had high protein and very high protein, they didn't eat a lot difference, again, because of the energy control in that, but they almost exclusively ate the low protein diet. This one was too high for them. And even with that, they still ended up by far with the highest protein overall in the diet. And for the others in between, you can see that they ate, again, roughly the same amount. There wasn't a lot of difference in total feed intake, but big differences in the quantities. For this one, they ate almost exclusively the high protein diet. This was about half and half. This wasn't far away from half and half. This one was more lower. And they were they did very much achieve about the same protein content, about 20.5% protein, despite the differences in the diet. So what it appears is that, I don't know how big these pigs were, let's say they're 40 kilos, that there is an optimal protein content, and within that, we're talking about amino acids, but this was just recorded on protein. There's an optimal protein content, that there's something there that they can pick, that they can actually choose to eat. And what we're trying to do is give them that at every stage in their life. So let's say this was pigs that are at 40 kilos. If you did this for 20 kilo pigs, you'd probably find a similar result, but this would probably be higher. If you did this for 60 kilo, 80 kilo, 100 kilo pigs, you'd probably find similar result, but this would probably be lower. And they're choosing to eat to those requirements. But primarily it's energy. It's energy to start with, and then they can, if given a choice, like we gave them here, they actually can then control their protein intake as well. So we're looking at feed conversion ratios, looking at how much an animal eats versus how much live weight gain you get. When we talk, feed conversion ratios are a measurement, if you like, of how accurately the diet is meeting the animal's nutrient needs. You can put a lot of feed in, but if it's not meeting those nutrient requirements, you're not going to get a lot of growth out. If the diet is very well balanced, you can put less feed in and get more growth and less wastage. So measuring feed conversion ratios is a good measurement of how close your diet is to that animal's requirements at any one time. A measurement of an animal's efficiency in converting feed mass into increasing body mass. And you can quite simply calculate that by measuring the amount of food that they eat divided by the live weight gain. So for example, a 20 kilo pig that eats 852 grams of feed per day and gains 630 grams of body weight will have a feed conversion ratio of 1.35. 1.35 kilos of feed in, 1 kilo of gain. And if your diet isn't balanced properly, they might actually have to eat 1 kilo of feed to get 630 grams. If you didn't get the essential amino acids right, if you didn't get the mineral content right, if you didn't get the essential fatty acid right, you could end up eating more, still getting 630 grams of live weight gain. Feed conversion ratio might go up to something like 2 kilos in for whatever the calculation is. And all you've really done there is wasted feed, caused pollution, utilized energy to get rid of any excess nutrients. Just because that diet wasn't balanced properly. And I've just, this, in a commercial, for some of you who may feed commercial diets, then they do break them down into sort of quite small pockets of the animal's life. So up to 12 kilos, and then you might get a creep feed. For a link feed would go 12 to 15 kilos. a weaner feed up to 30, pig grower up to 60, 60 to 90, a finisher or withdrawal feed, or depending on what weight you're taking them to, maybe 60 or 100 as well. And you can see naturally, even with a balanced diet, the feed conversion ratio will go higher as the animal gets older. That's just what happens. They're most efficient at converting feed when they're younger. So what we ideally what we will do is maximize that, so that at these younger stages, at the weaner stage, at the grower stage, where you can get a lot of meat out for feed in, that we make sure that we're giving them the nutrients they need at that point. Because as they get older, even with a very well-balanced diet, they naturally will take more feed to get that 1 kilo gain. So there's just some figures there. Someone mentioned about quantities. How much more would they eat if it was cold? I don't know. I think if you've got small numbers of pigs, it probably wouldn't be that noticeable, to be fair, especially if it's a high energy diet anyway. If you've got 20,000 pigs in a shed, it probably does become more noticeable that you're going through the feed more quickly. I don't think it's going to be a massive increase, but there is an increase there.
Victoria, what's the ideal food conversion rate figure? Someone has asked.
Well, these would be targets. The ones on this, these would probably be the best you could get, I would say. These are the sort of textbook commercial figures. Okay. Possible, but that would rely on balancing essential amino acids to energy as closely as you could. And I've got a slide on it in a minute, actually looking at those requirements in more detail. But this is probably the best you could get in a commercial breed.
Okay, thank you.
But it soon drops. It's quite interesting when you start to change diet around, just how fast that goes up and how much more you've got to put in to get 1 kilo of live weight gain out once the diet's not so well balanced. So what I've got here, we're just going to have a look at growth rates, look at graphs here. So this graph shows the pattern, if you like, for growth. So this is conception. This is birth here, 0 days of age. And you can see that the little piglets won't grow very quickly because they've got to come out. And then once they're born, growth increases exponentially, and eventually it will tail off and they won't grow anymore. And that pattern is set genetically. So we can't go above that line. As when we're feeding them, what we're trying to do is trying to reach that line, trying to maximize their genetic potential by matching their requirements for this line here and maximizing growth at these stages when they are genetically predisposed to growing. Yeah, once they get to adulthood, doesn't matter how much you feed them, they're not going to grow anymore. You can change this line. So if you want them to grow more slowly, you can. You know, if the line can go, if you can imagine it going like that, that's fine. That's okay. You'll get there in the end. It will take more feed to do that. You'll have poorer feed conversion ratio doing that. But as long as you're balancing the nutrients and dropping them both together, dropping both the protein and the energy content equally, then you can have slower growth. And that's not a problem at all. As I said, it just means you're going to utilize more feed for maintenance, and therefore it won't be as efficient. But if you're trying to get as efficient meat production as you can, then we're trying to maximize that line. And if you just look at this graph here, this is the same time period, but it's just breaking down the deposition of the individual tissues. So we're still following this graph here, but what we're now looking at is how the animal actually achieves that growth. So this red line here shows the deposition of bone from conception through to adulthood. And you can see when from sort of fertilization through growth of the fetus and young animals, bone is kind of the most important thing, because these animals have got to get up and run and suckle very quickly after they're born. And so at those stages, at the earlier stages, then the animals want to lay down bone. They're genetically primed to lay down bone. And the yellow line is the protein. So this would be their skin, it would be their tissues, it would be their heart, their lungs, their spleens, their skin, what little muscle they have, the hair, etc., the trotters. Yeah, it's not just the muscle tissue, it's all of those other tissues as well. And you can see again that they're very important. So there's a predisposition to be laying down protein as well. They want to lay down protein, they want to lay down bone in the early period. And the fat one really is negligible, really. They don't want to take up space, precious space with fat. They need minimal amount of fat. They just need enough brown and adipose tissue to be able to get up and get their first suckle. So they're not primed to lay down fat at this age, because as I said, if you've got however many 13 piglets inside, fat's just a waste of space, really. It's the protein and the bone that are important. And as they're growing, you can see that first of all it's the bone that stops first. The bone becomes less important because they've put on that height, if you like. They've laid down the bone, just like humans. If you think about teenagers, they grow very quickly, but they're quite slim. They don't have a lot of muscle tissue on them. And then it's the protein that does start to die away next, and eventually they stop accumulating protein. There's always a requirement for protein because protein's always being turned over, but they stop accumulating protein. And unfortunately for us, the fat just becomes easier and easier to put down. And you can see it never stops, unfortunately. So as what we've got here, and again, this is genetic, it depends on breed, modern genetics, which animals that have been selectively bred for certain characteristics here. But if we're killing them, for example, here in their lifespan, we're killing them where there's an exact difference between protein to fat, lean to fat, carcass to fat. And as far as we can, the further we get them along the line, the bigger they're going to be. But we're trying to keep this yellow line as high as we can and keep the green line as low as we can, really, so that we get maximum live weight to achieve that carcass composition that we need, that exact ratio of fat to lean that we need to give the pigs that taste, the marbling of the fat, that back fat that people like on bacon, the marbling of fat through the muscle tissues that gives meat that mouth feel. We need fat in very lean meat, doesn't taste of anything. And it's just to get that exact proportion of fat to lean. And what happens is, if we feed a diet that is low in amino acids, low in protein, but high in energy, then this yellow line starts to fall faster. They start to put down less protein because it's not there, because the lysine or the methionine isn't there. And so if you can imagine, if you could see us here, the yellow and the green line come together faster. And if you're killing to achieve that specific carcass composition, you're going to have to kill them earlier, which means they'll be smaller.
Victoria, I've got a question. Well, a couple have just come through now, so seems very interesting. They say, do you recommend ad lib feeding pigs when growing for meat if the diet balance is correct?
Yes.
Okay.
Yes, that's easy.
All right. And then ad lib feeding in outdoor setting would encourage vermin and wild birds and domestic ones, ducks. So we don't do that.
It's not a problem
Mm-hmm.
because as long as the diet is still balanced, this will just happen more slowly. Yeah, as I said, you're going to get a line that grows slower. They'll get there eventually, but
Okay.
But by keeping the protein high, keeping the energy low, you're still maintaining that differential between the fat to lean, the protein to energy. What causes the problems is when we change that difference in the diet, where we either drop the essential amino acids, it's not really the protein content, it's dropping the essential amino acid content, or increasing the fat. If we feed it, and this, I'll show you in real life an example at the end on my spreadsheet, but if we feed something that is higher in fat than the need, then this green line is just going to go up faster. They will store excess energy as fat. And so if that green line goes up faster, that if we want, let's say we want an inch between these two, it's going to happen earlier, and there'll be lower weight at that particular carcass composition. And if you kill them at the same time, they'll be too fat.
Okay, thank you.
Okay, so as I said, don't overfeed protein, because they just have to use energy to get rid of it. They have a template of what they need genetically, following this graph and that graph. Anything extra protein just means they've got to get rid of that nitrogen group. They can't, too much nitrogen's dangerous, and that just ends up being excreted and possibly causing pollution. But if you underfeed protein, then you're dropping this yellow line down, and you're going to get a carcass that is over fat earlier than it needs to be. Likewise with energy. If you underfeed energy early on, it's probably not that much of a deal, really. They'll eat more. They'll just eat more, which means they eat more amino acids, which they'll have to get rid of, which utilizes energy, but probably not the end of the world. But if you overfeed energy, then they're just going to get fat earlier, and you're either going to end up killing them at a very small weight, or they're going to be too fat when you kill them. Okay. So,
sorry, Victoria, I've got another question.
It's fine. No, it's great.
Says here, for a traditional breed, should you still follow the different diets as they prescribe to commercial breeds? So i.e. you would feel a weaner feed, then a grower feed, and then a finisher feed.
Good question. I'll just show you my next graph here, because that's probably a very good question. So you can see there, if you're in a commercial situation where you've got enough pigs to be able to warrant buying all those individual different feeds, those feeds are designed to follow that yellow line. So the protein content, or the lysine content, if you like, more specifically, of a creep feed will be highest at creep, and that lysine content, and I've got a slide on this in a minute, table, that lysine content will come down, and the energy content will change in proportion to the lysine as the green line goes up. With the traditional breeds will mature earlier, which means probably this green and yellow line will come together more steeply. Yeah, it's an earlier maturing breed means that they'll be at a lower weight when they hit that carcass composition. When we talk about maturing, we're talking about the rate that these lines change. So for a more traditional breed, what you would probably find is, if you can imagine this yellow line coming down more steeply, and what that might mean is you have to keep the protein high at the beginning. You might not need a protein content as high as the finisher here, but likewise, you'd have to be more careful of the energy. I don't actually think there's a huge amount of difference. There will be some differences, as I said, because they mature earlier, which means the yellow and green line will come together more quickly. I don't think it's a massive difference. What it means is you probably just have to kill them at a lower weight to achieve that carcass composition than, for example, a commercial breed. Not massively lower, but maybe just slightly lower. But you can see that if you've got 20,000 pigs, then you can feed 6, 7 different diets, and you're following that yellow line, and you're giving them just the exact lysine to energy ratio at every stage in their life, which is going to be most efficient. If you haven't got so many pigs, then you might feed something like a sow weaner grower there, and then drop that down to maybe a grower finisher there, which it's a compromise, but it's fine. It's fine for smaller producers. And as I said, this black line is the point at which we kill them. It very much, as I said, it depends very much on how well you've been able to keep the protein up and the energy down, and to achieve that carcass composition at that key point in their life. Okay, but what we're trying to avoid is underfeeding protein here, not feeding enough, or underfeeding lysine, and overfeeding fat. And then what we're trying to avoid, overfeeding protein here as well. We're trying, whether you're in a big commercial situation or a smaller producer, we're still trying to follow those yellow and green lines as closely as we can to achieve efficiency. So what we're really looking at is this ratio of lysine to energy, not so much protein to energy, because the protein, you could have a protein amount in a diet, and that protein could be all non-essential amino acids, which is no good. We're looking, so when we measure this ratio, we're measuring it as lysine to DE, what in a feed. When determining the ideal ratio of lysine to DE, consideration must be given to genetics. So that's where your certain traditional breeds would come in. There could be a slightly different lysine to DE ratio. The lysine maybe needs to be slightly higher. But no, it won't be massively different. But if you wanted to tweak it, you probably could. Different environments, i.e. if they're outside, you'll have to increase the energy a little bit, and market price as well, and just what market you're aiming for. But roughly, again, we're just looking at the different ages here. You can see when we're looking at this lysine to DE ratio, it's about 1-to-1 early on. And then as they get older, it drops. So the ratio of energy to lysine drops 0.8, 0.7, 0.7. And so as long as you can achieve that, you can grow them slower, but still trying to maintain that yellow energy, lysine to DE, yellow line to green line. Yeah, these figures here are commercial figures, where we've got, so again, but it's just really to highlight. You can see early on that you're looking at like a percentage of lysine in the diet of 1.6, 1.5, 1.4, which drops right down in line with the yellow line. The energy content does drop as well, but in a different proportion. As a proportion, it's going up.
So Victoria, 2 questions that have come in, one of which was, what is the required ratio of all essential amino acids?
Well, I don't know it off the top of my head, but someone does. And if you were to, there will be something out there that will tell you for those 10 essential amino acids, exactly how much of each essential amino acid is needed at all of these stages. There's a lot of work being done on, I think it was back in the 1980s, really, it was a long time ago. But if you gave me a chance to go away and find my book, I would be able to tell you exactly how much methionine, threonine, tryptophan, isoleucine is needed at any stage in their lives. Yeah, and I guess that's what we call ideal protein. If you could add amino acids, all 10 of them, to make up a diet, you would end up with exactly what you needed, plus a few extra non-essential amino acids.
Maybe you can give that to us later on.
Well, I'll go away and look.
Yeah.
In fact, Anna, if you've got your book, go and see if you can find that.
And then the last question was, what should we feed sows and boars when breeding from them? Is there a different diet?
So commercial sow diets, probably you can get a sort of they call it like a single sow, which will be enough for both lactating and pregnant sows. How much? I think I had it in my, what did I have that in my list somewhere? How much to feed them? 2 to 2.5 kilos of dry sow. Up to 6. Again, they'll be commercial figures. You might find that yours. Boars, probably more like dry sows, maybe a little bit more. But these would be sort of diets. A single sow would be fine, or an individual dry to lactating sow would be fine as well. But with the dry sows, it's making sure they don't eat too much, making sure they don't get too fat. They don't have a massive extra requirement at pregnancy, but they've got a lot of room inside them. So the temptation is to fill them up with sow feed, for example, but that tends to be very high in energy because of this. And so you're better off giving them 2.5 kilos of dry sow feed, and then something like sugar beet, which will swell up inside them, or straw. Let them have straw, so they don't feel hungry. Usually under normal circumstances, the metabolic factors kick in, but it's just these dry sows, because they've got such a capacity to eat when they're pregnant. They can't feel hungry, but we don't want them to get too fat. Okay. I think I've only got a couple more slides, and then I'll show you this spreadsheet, and then we can take any more questions. How do you manipulate carcass composition? I can get a very lean carcass. I can get a very fat carcass. There's different ways of doing it. If you want a very lean carcass, then you limit the energy. Feed a diet that's as high as you can go in terms of meeting requirements for lysine and other amino acids, but limit the energy, keep the energy down, and that prevents them. They'll use the energy for all the metabolism and digestion and running around, and they won't have a lot of extra energy to be laid down as fat. And so you can get a very lean carcass, but as I said earlier, a lean carcass is not very tasty. A very lean carcass doesn't have that taste, it doesn't have that mouthfeel, you won't get the back fat on the bacon. It's not really what we want. It's about matching the ratios. You can slaughter at an earlier stage of maturity. So if you slaughter them when they're very young, if you keep in mind that graph, the yellow line and the blue line, as opposed to the green line, red line even, as opposed to the green line, then they will be leaner, but then they'll be smaller. So there's a compromise there between getting as much meat as you can, but still achieving the carcass composition. You can use later maturing animals. So our commercial breeds have been genetically selected to if you can imagine, drawing out those yellow and green lines, just making them, stretching them out so we can take them to a higher body weight and still achieve that carcass composition. That's just done through years and years of genetic selection and using breeds that mature later. Sex has an effect. So in terms of efficiency, they go in the order of uncastrated boars, then gilts, then castrated boars, what that means is the castrated boars will mature first. They'll go fat first, then the gilts, then the uncastrated boars. It's a bit different to cows, where cows go bulls, castrated bulls, heifers. But with this, it's slightly different. It's the castrated boars that will go fat first, which is why a lot of the time they leave the boars uncastrated. And none of those are a problem. It's all just about picking where you kill them and you know, still being able to achieve that carcass composition, but it will affect, I guess, taste or how big they are when you slaughter them. And there's a lovely picture of Andrew's piglets. Very cute. So I said I would finish, let me just get rid of that. I said I would finish with just a little example here of, this is just a simple, if you can imagine that if you're a home mixer, if you're someone at home who's feeding or home mixing or buying a pig grower feed, for example, and adding to your feed, then this, you could, I mean, I can give you this, it's not a problem. This is just a spreadsheet that I made, but it's a nice example of just showing what happens when you add things to feed or when you mix certain feeds together. Okay, so we're talking, this is just an example of a grower ration. So you can see here in this particular example, I've put in a pig grower feed, 40 kilos, we'll talk about 40 kilos. And if you can remember from my slide earlier, I said for the pig growers, the lysine to DE ratio should be 0.8. That's what we're looking for. That's the fat to lean ratio, or fat lysine to energy that we're looking at in this diet. So in a commercial pig grower feed, that would be perfectly balanced to give us 0.8 lysine to DE ratio. Yeah, because somebody has kindly added lysine, neat lysine, and also possibly methionine and other things as well. They've balanced that perfectly. So if you bought that and fed nothing else, you'd be feeding an exact lysine to DE ratio of 0.8, which would be right at that for that particular period of their lives. So what I've done, we're just going to look, here's the lysine content here. Here's the energy content here. It's these two figures that we're going to look at. And so, for example, what I've said is we're looking for a lysine content of 1.05 and an energy of 13.3 megajoules per kilogram. But that's the target, if you like. It was in the table earlier. That's the target that we need for this particular age group. Let's say you get a supply of bread, for example. Pigs love bread, don't they? They love donuts and things like that. So if you buy commercial pig feed, but you then have a source of maybe bread, cakes, etc., something like that, not from your kitchen, but maybe from a shop, from a retail shop or a bakery, and there's no pies in it, it's just bread, and you offer them, let's say we're going to offer them 10% bread, which means that they eat 90%-ish of their grower feed. They're only going to eat a certain amount. Look what that's done to this ratio. And that's because bread would be low in protein, very low in lysine and methionine, but high in energy. And bread is really disbalanced compared with what we're trying to do here. So by 10% bread, if they're eating 2 kilos a day, and we put in 200 grams of bread, doesn't sound like an awful lot, does it? It's probably only, what, a couple of slices of bread each? But that has a massive effect on the lysine to DE ratio. So you can see the lysine's dropped there from, should be 1.05, and it's dropped to 0.95, and the energy's gone up. So imagine the yellow line's come down, the green line's gone up, the ratio's dropped, and they'll get fat very quickly. Doesn't sound like a lot, does it? 10%. Vegetables, someone mentioned vegetables earlier, and I said I would come back to it. Vegetables are slightly different because vegetables are just low in everything. Yeah, the bread's massively unbalanced, low in lysine, but very high in energy. Vegetables like, I think you mentioned kale and broccoli, 10% of them, it doesn't make a huge amount of difference. It does drop the ratio slightly. It drops the overall content of both. It drops both the lysine and the DE ratio. That means they'll grow more slowly, but it doesn't knock the carcass composition out too much. They shouldn't really go, they shouldn't be overfat. It just means they're going to not grow as quickly as on the commercial feed alone. But that's not a problem. I mean, I'm guessing it's not the biggest thing for you is to have them grown too quickly anyway. Someone mentioned peas. I think you said peas earlier, didn't you? So I don't think I've ever done this. If we put 10% peas in there, let's see what that does. So interestingly, the peas have increased the lysine, but massively increased the energy. These are based on my, oh, hang on. Oh yeah, no, peas on 36% protein, energy, are they? Sorry, this is what you get when you fiddle around with a spreadsheet. There you go. Okay, so peas are all right. Peas are about 20% protein, 15 energy, for example, maybe even a bit higher. So that's okay. Going back to the bread, what I just wanted to say there is the bread itself is massively unbalanced. But if you want to feed bread, if you've got a supply of bread, or it might be barley, barley's similar, you've got a supply of barley. It's not quite as extreme as bread, but barley has a similar effect because it's quite low in protein, but high in energy. And if I just go back to the bread, if you want to feed bread, if the pigs like bread and you've got a good supply of bread, you might want to look at supplementing it with perhaps some soya. So if I just add, you can buy a bag of soya from your local farm store. 3% soya, it's nothing really, it's going to be a very small amount. But you can see how that, by adding soya, if you can imagine sprinkling perhaps half a bag of soya onto the bread, onto the mix, for example, that you can see how doing something as easy as that is starting to bring that lysine to DE ratio back up again. So I'm not saying don't feed bread if you've got a nice supply of bread and they love bread, or donuts, even worse because of the oil content of donuts, but they do love donuts, don't they? And cake. But you can deal with the worst effects of it, often with something quite simple, like getting a bag of soya from your local store and just sprinkling a little bit of that on. The thing you have to just bear in mind if you're going to do that is if you're still using 90% of the pig grower feed and you're only adding 10% of these other things, you're not going to massively change the mineral content, the vitamin content, the essential fatty acid content. We're primarily concentrating on lysine to energy ratio here. But if, for example, if you start to bring your proportion of pig grower feed down to 50%, for example, and then you were to start supplementing it with, I don't know, whatever. I'm just playing around here. But if you, just so for example, that was your diet. I mean, it's not great, but just what you have on top of trying to think about lysine and energy, you've now decreased the vitamin content by almost 50%, the zinc content for almost 50%, the essential fatty acid content by almost 50%. And you have to, if you're going to supplement it with something like that, then you would possibly have to look at feeding like a simple mineral supplement. Buy a 25-litre drum of sunflower oil and put some of that, offer them some of that to get the essential fatty acids in. That's probably that's diluted too far. And it would need some kind of, not just balancing for lysine and energy, but also thinking about bringing the other nutrient values back up, the vitamins, the minerals, and the essential fatty acids.
So what about apples, Victoria?
Right, so apples, well, I haven't got apples on here, but I should put apples on here. But let's, does anyone give me a rough idea of the nutrient content of apples? Does anyone know what the protein content of an apple is? It's got to be low, hasn't it? 6%, 7%?
Something like that.
And anyone know what the energy content of an apple is? It's high in sugar. These are in megajoules, not calories. We probably all know what calories are. It's probably quite high, I would say. Let's put it in at 14. I don't know, for example. And let's say you want to put 10% apples. We'll just work on that for now. It has brought it down quite a lot. Oh, hang on.
Yeah.
Yeah. Not as bad as the bread, because the bread is extreme. But still, if you're only putting in 10% apples, it's probably fine. If it's more than that, they'll go fat too quickly on that.
Okay, and another question was, if you had a supply of barley and soya, how much could you reduce your pig feed by?
If you were only feeding soya and barley, you could theoretically you could reduce your pig grower feed completely. But because soya is quite low in lysine, you'd have to feed a lot more soya to achieve the lysine. You'd end up, if you can imagine the lysine being one of the lowest constituents of soya protein, and you're feeding to achieve that lysine content first, you end up feeding an awful lot more of all the other essential and non-essential amino acids to achieve the lysine. So you can do it just with soya and barley, but you'd have to feed extreme amounts of soya to get the lysine content. And people do, don't they? There are people out there who home mix with just soya and barley, but commercially they'll be buying a mineral supplement that has got supplementary lysine, methionine, threonine in to make up for the shortfall in the soya. It's not a problem. You would just end up overfeeding protein.
And what would the percentage ratios look like if we had 80% grower feed and we put 20% rolled barley in there? What would that look like?
80 pig grower feed, did you say?
Yeah. Okay.
Not great.
Mm-hmm.
The energy's right, look. See, the energy content's about spot on
Yeah.
there. But it's the lysine, it's the essential amino acids that have dropped right down. So again, what that means is that yellow line will come down quickly. And if you're trying to achieve the differential, it will happen earlier. So you'd either kill them earlier to achieve the same carcass composition, or kill them the same and they'd be too fat. Like I said, I mean, I know pigs love these extra things like the apples and the barley and the bread and the cakes. And I'm not saying don't do that. I'm just saying there's ways of dealing with it by adding the bag of soya, adding the sunflower oil, buying a really simple pig mineral and adding a little bit of that as well. Because otherwise we're feeding all these lovely amino acids and all this like protein, and we're not going to get the growth. Yeah. All of the building blocks are there except the zinc, for example.
Mm. I don't. Sorry, Victoria. There's. I think it was sometime later last year. Someone had mentioned that mineral blocks had been released for pigs, and they were called Pig Licks. So PIGLIX, I think it was. Is that a gimmick? Have you heard of them? I
have heard of them, yes. No, I mean, they're probably quite a nice idea in this situation where you haven't actually got to measure out minerals and sprinkle them onto wet bread or something. That the pig will take an amount of those licks, and in it will be not lysine, but it will be the B vitamins, for example, that they would need, other vitamins, the zinc, and all of those things needed in small amounts. The thing about the pig licks is you can't monitor or manage how much they're going to eat, so you wouldn't actually know whether they were eating any and just kicking them around, or whether they were munching their way through them. But I wouldn't say they're a gimmick. I would say they would work. It's just more difficult to actually know how much they're getting.
But it's not detrimental to them if you just threw them in and they'd have it ad lib on top of their normal concentrates.
No, I can't imagine they'd ever eat too much for it to be a problem. Mm-hmm. Until you see them like munching through them one day, with munching a whole one in its mouth. I think, I've just spent £10 on that.
Okay, thank you.
Okay, so that's my last topic. Has anyone got any more questions there, or does anybody got any? Do you want me to run any more calculations through this?
Well, there's two more questions that have come in. With feeding potatoes, although we use the pigs to root out last spuds, we also boil up a big pot outside twice a week. Is this okay?
Yeah, I'm sure it's fine. The potatoes are a bit like the vegetables. If the protein's low, the energies, I know you think about potatoes being starchy, but they're not really that high in energy. So it's probably not going to make a massive effect on the ratio. I can put it in if you want. Depends on what ratio not a massive effect. If you're boiling them up, the only thing is if you're boiling them up, you'll lose some of the B vitamins. So if you were saying, if it was 50-50, for example, that would have an effect. But by cooking it, you would lose a lot of the B vitamins, the essential B vitamins in there.
Okay. Another question.
But it sounds tasty.
Yes. Another question for you, Victoria, is there an industry standard for commercial feed? For example, a certain percentage of different minerals, etc.?
There will be, yes. I would imagine you could buy 3 or 4 different commercial pig grower feeds and they would all have very, very similar vitamin and mineral content. Not overfeeding, but meeting those nutrient requirements that they did all that research on in the 1980s. I don't know what it is off the top of my head. I wouldn't like to say, but there will be a sort of an industry standard that you would see on the labels.
So I've got a question for you, Victoria. I don't know where you stand on this, but over the last, I don't know, say 3-4 years now, we've seen various articles about insects being used for a protein source. So there's, I don't know, locusts and dried mealworms, I think.
Yeah.
So what? How is that all being integrated with the feed, if at all?
Well, on paper, insect meal is actually lovely for pigs because it does have a very high level of essential amino acids. So it not only replaces soya, it goes further than that. It also replaces some of the synthetic amino acids as well. So I think in the feed industry, we're being scrutinized all the time for soya usage. At the moment, it's looking at sustainability and the costs both to climate and money-wise of bringing soya in from North America, South America. And so something like insect protein would certainly contribute to reducing our use of soya, which we're under massive pressure from the retailers to do. So I think in the industry, they probably are looking at it very closely. At the minute, you can't feed it, but if it ever was allowed to be fed, then I think it would have a very nice place in pig and poultry diets.
Thank you. Anybody else got any questions? I think we can open the forum if you wish. No? We've gone a bit shy now, Victoria.
Well, you have asked lots of questions.
There have been lots.
The session, so that's very good.
You talked earlier about growth and the genetics of growth and how the feeds and nutrients affects the growth rate. So if you were poorly feeding and there's low nutrients and your pigs aren't growing, and hence then you will have small pigs, then those pigs will go on to breed and they will also, there's nothing that you can do, or is there something you can do with regards to growth rate? So if they're, what I'm trying to say, if they're born from a small pig that was poorly fed, can you help a pig from a poorly fed pig to grow and enhance its growth?
Well, theoretically, they should have the same genetics. So,
right, that's what I thought.
If the mother has been very badly fed and she was weak and never really grew into herself almost, but the piglets, well, if she didn't have enough milk, if she wasn't being fed the right diet during lactation and they didn't have enough milk, then the piglets are going to end up the same. But if you could catch the piglets from when they were born and do everything that we've talked about there, give them all those nutrients to meet their genetic requirements, there should be no reason why they can't go on to achieve what we've been talking about, because the genetics won't have changed in one generation. But the chances are, if you've got a mother that's poorly fed and nothing's changed, then she's not going to have enough milk.
No.
And or the milk's not going to be of the right consistency, the right constitution, and therefore the cycle just keeps going.
Mm-hmm.
It's Andrew. I have a question. So I always remember my grandmother telling me back in the 80s the eggs from the egg man always tasted a bit fishy, and that was because they used to feed milk to the chickens because the protein content helped with the egg production. Is there, ball taint aside and all that, is there an impact on flavour with the kind of proteins and stuff you're feeding to what comes out, not just yield?
I think if you fed a lot of fish meal, there may be a risk that possibly some people might pick it up, not everyone, but some might. But I mean, if I should put fish meal on here. You can buy bags of fish meal from your local agricultural merchant.
Yeah.
You would only need a tiny amount of fish meal to make up a shortfall that the bread would give or the barley would give. It would actually be a lovely substitution. And the pigs would love it. And I doubt you would get any noticeable taint from that at all.
Just a question, I mean, I've never, whole boar tape question's another one that's supposed to be genetic, but I just wondered because, I always remember my grandmother telling me, oh, he's got those eggs again from that farmer because it all tastes like bloody fish and cod liver oil tablets.
I doubt it really. I think if you were to, as I said, if you didn't, some people don't want to use soya for the reasons I said earlier, for sustainability, the fact that it's possibly GM. If you're organic, for example, then you can't use GM soya. But and in those situations, fish meal is an even better substitution for soya, and you would need less. Fish meal is 66% protein, so you'd need even less of that. Very high in lysine and other essential amino acids. So a little bit of fish meal would make up for a lot of those extra things, and I don't think you would taste it.
No. Thank you.
Another, I think this might be the last question that we've got here, Victoria. So in Ireland, they sell a general organic feed called IP Pig 95 that is used for all stages. Is this a gimmick?
No, I wouldn't say it is. I wouldn't say it is. Like, it's kind of going back to what I was saying here, where we have a diet that sort of fits everything. This sow, weaner, grower, possibly even a finisher as well. And it sort of just sits in the middle of everything. It'll underfeed protein at the beginning. It'll overfeed it at the end, but everything will be okay on it. And if you've only got a couple of pigs, it's fine. It's fine for that. Where you're looking more closely at meeting the nutrient requirements and, achieving a better carcass composition or achieving it more cost effectively, that kind of product will probably cost you a lot of money. Because what would probably happen is you'd be feeding more protein than you needed towards the later stages. But it's a compromise. Like I said, ideally, if you remember the pigs with the two pens of the different feed and they chose their own. If you think about that, if you left them to it, every day they would choose slightly different proportions. They'd choose slightly more of the lower protein and more of the higher one because they're following that yellow line. And what we're trying to do is within whatever systems we have, trying to do that same thing. And everything's a compromise, I guess. It's just how able you are to change your diet in line with the protein requirements.
Thank you, Victoria. Conscious now, we're 9:20, so we are over, but that's based on the volume of questions. And Victoria, I thank you for taking the time to address all those. Does anyone else have any? I know Kim's done a great job of reading all the messages that come through and asking all the questions. Are there any questions outstanding that you'd like to ask from Victoria?
If you have got a diet and I can either send you that spreadsheet, or please feel free to email us and I'll quickly stick in whatever you're feeding and send it back again. It's no problem. Thank you,
Victoria. So
thank you.
I think this has been, one of the widely attended events we put together. I mean, I think, with feed and stuff like that, and questions like that. It's good for people to know. A lot of people will just waste time feeding. They get given food and they feed it to their pigs, and it's great for bulk feed to make them feel content, but it's not good when the end carcass comes and someone says, "Oh, I fed this pig until it's 10 months old and it's really lean." Yeah, but you spend 10 months feeding the pig that should have gone off 4 months ago, so with a lot more fat and a lot more flavour. But just want to say thank you very much for your time, Victoria.
No problem at all. No problem. It's been nice. I can only see a couple of you, but I can see a list of people, so it's really nice to have such a good turnout.
We've had a good turnout, which is much appreciated. And thank you to everyone that's asked the question as well. Without the questions, that's what drives the interaction with these questions. So if there's nothing else, I'd say thank you everyone for their time, giving up their evening to attend. And again, thank you, Victoria, for your superior knowledge and your ability to answer all these questions that have been thrown at you.
No problem. Thank you for asking us.
Thank you very much, Victoria.
Yeah, much appreciated. So
thank you everyone for attending too. Thank you.
Thank you very much. Take care, everybody.
Bye.
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 Bye. Bye, Stuart.
Hi, Kim.
Bye.
Bye.
It's like the Waltons. Bye-bye.
Yeah.
Bye.
Very much.
Night. Good night, Anita.
Night. Good night,
John
Kimberly.
That's great. Thank you very much, Victoria. That was a really useful.
Brilliant. Brilliant.
It
No
was
problem.
received well. Like I say, we met 5-6 weeks ago when you gave it to the AHTB broadcast, and I knew it would be received well. And we've had 25 people turn up tonight. I very much suspect we'll get 4 times that listen to the replay. So,
Well, if you want us to do it again, it's no problem. But I don't really need to. If actually, like you say,
it's very, very, very knowledgeable. You clearly know your subject inside out, and it's a very common bit we get on the group about what to feed. I've got this and I've got that.
well, if there's anything if anything comes out of it where some people are specifically interested in certain diets and you want us to do something related but different, just I will have slides. I won't have to spend preparing. I've got slides on everything, and maybe later in the year or something we could do another one.
Obviously you run a business that talks about nutrition and stuff. You obviously work very closely with the commercial sector and stuff like that, so taking your time out for a small percentage of us that try to make the most of the rare breeds is much appreciated.
Yeah.
Well, if I ever got room for a pig, I'll come to you and we'll have some of them because they are the cutest pigs ever.
That's
So
what
you
we
might be
like
able to
to
help
hear,
me.
Victoria. We like to hear that.
Drive up to the rainy, stormy, snowy areas of.
Yeah. They have to be hardy to live in concert, but if they're hardy,
in the middle of summer to drop you off a couple of piglets. That would be,
I don't think my husband will be very happy because he already has to look after the kids and the dogs and everyone else all the other waifs and strays that I bring home. So a pig might be too much, but one day I'll have a pig and then I'll come to you.
Anyway, thanks again, Victoria.
No problem.
Thank you.
Take care.
Thanks then. Bye.
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 Well, thank you very much, Victoria. I'm sure you'll agree that was a very interesting session. If anyone does have any questions as a result, please reach out to us. Drop us an email, hello@oxfordsandyandblackpiggroup.org, and we can try and answer them for you or direct them to Victoria to see if we can get you some more information. That's it for this episode. Just a reminder, Big Fat Pig Quiz, July 23rd, 7 o'clock. Tickets in the shop, just £3. Until next time, I've been Andrew O'Shea. Happy pig keeping.